The line depicting the total risk and expected return of portfolio combinations of a risk-free asset and any risky asset is the security market line, capital allocation line, or security characteristic line. So it's the line depicting total risk and expected return on the portfolio. And remember, we had the risk-free asset. What is that? That's not beta, so it cannot be a security market line. So it's either a capital allocation line or a security characteristic line. It is a capital allocation line. 2, the portfolio of a risk-free asset and a risky asset has a better risk-return trade-off than investing in only one asset type, because the correlation between the risk-free asset and the risky asset is equal to, what is the correlation of the risk-free and the risky asset equal to? Well, if one is risk-free and the other is risky, correlation must be 0. 3, with respect to capital market theory, an investor's optimal portfolio is the combination of a risk-free asset and a risky asset with the highest, let's be careful here, it's an investor's optimal portfolio with the highest expected return, indifference curve, or capital allocation line slope. And you have to go back to the last reading and combine it with what we have so far. It is the highest indifference curve. 4, highly risk-averse investors will most likely invest the majority of their wealth in risky assets, risk-free assets, or the optimal risky portfolio. Well, if they're highly risk-averse, remember that's what we have here. There's the optimal risky portfolio. That's a lending portfolio. That's a borrowing portfolio. And if we drew indifference curves on there, that's A equals 2, A equals 3, A equals 4. The higher the A is, remember it was the expected return minus 1/2 A sigma squared, the measure of risk aversion. The higher the A, the more risk averse. Well, the higher the A, the closer we get here. This is the risk-free asset down here. This is the optimal portfolio. So if highly risk-averse investors will most likely invest the majority of their wealth in risk-free assets. 5, the capital market line, CML, is the graph of the risk and return of portfolio combinations consisting of the risk-free asset and any risky portfolio, the market portfolio, or the leveraged portfolio. Well, what's this word here? Capital market line, which means it connects with the, or it's a combination of the risk-free asset and the market portfolio. So let's look for market in here. There we go. 6, which of the following statements most accurately defines the market portfolio in capital market theory? The market portfolio consists of all risky assets, tradable assets, investable assets. Now you're probably looking at this going, but aren't they all true? I remember tradable, I remember investable, I remember risky, aren't they all true? Well, it's saying most accurate. The most accurate is risky assets, and here's why. The portfolio of all risky assets are those assets that are tradable and investable. So risky assets are tradable and investable assets. Tradable assets are just tradable assets. Investable assets are just investable assets. Risky assets are ones that are both tradable and investable. Since we're looking for most accurate, the most encompassing definition. So if you think about it as Venn diagrams, there's risky assets. Here are all your tradable assets. Here are all your investable assets. Obviously, they're inside the grouping for risky assets. 7, with respect to capital market theory, the optimal risky portfolio is the market portfolio, has the highest expected return, has the lowest expected variance. Well, the optimal risky portfolio, again, capital market theory, optimal risky portfolio is the market portfolio. That's almost a repeat of one we've already had. 8, relative to portfolios on the capital market line, any portfolio that plots above the capital market line is considered inferior, inefficient, or unachievable. So let's see what we have. There's the capital market line. There's our risk-free rate. There's the CML, which means that there is our market portfolio. Any portfolio that plots above the CML, here, here, or here, is inferior, inefficient, or unachievable. Well, Well, anything above is unachievable. Anything below is inefficient. 9. A portfolio on the capital market line with returns greater than the returns on the market portfolio represents, well, how do we get that? There's our market portfolio. And it says any portfolio, it's on the capital market line. So it's got to be on the capital market line with returns greater than the returns on the market portfolio, which means if these are the returns, and if we have returns greater, it must be on the capital market line. What is that? A lending portfolio, a borrowing portfolio, or unachievable. If it's on the line, it's achievable. We can get rid of that. We got to decide whether it's lending or borrowing. And it is a borrowing portfolio. 10. With respect to the capital market line, a portfolio on the CML, again, it's on, with returns less than the returns on the market portfolio. So if these are the returns on the market portfolio, we have returns that are less, but it's on the capital market line, is lending, borrowing, or unachievable. If it's on the line, it's achievable. We just have to determine if that's a lending portfolio or a borrowing portfolio. That is a lending portfolio. 11. Which of the following types of risk is most likely avoided by forming a diversified portfolio? Type of risk that is likely avoided. Total risk, systematic risk, or non-systematic risk? Well, systematic risk is risk that you can't get rid of. That's the market risk. So you cannot avoid that by diversifying. So it's either total risk or non-systematic risk. And total risk is systematic plus non-systematic. So what is most likely avoided? The non-systematic. 12. Which of the following events is most likely an example of non-systematic risk? That means it's risk pertaining to the particular security. A decline in interest rates, well, that would affect all securities, so we can get rid of that, right? Eliminate as we read. The resignation of a CEO, well, there we go. That would most likely be an example of non-systematic risk. We can take B and be done with it, but we'll read C and see if we can't delete it. An increase in the value of the US dollar, well, that is market risk. That would affect all securities that have exposure to the US dollar, so we can eliminate that. 13. With respect to the pricing of risk in capital market theory, which of the following statements is most accurate? All risk is priced, systematic risk is priced, non-systematic risk is priced. Which is most accurate? Systematic risk is priced. Not all risk is priced. That would be saying both systematic and non-systematic is. And we know non-systematic risk is not priced. We're told specifically you're not going to get paid for it. Systematic risk is priced. 14. The sum of an asset's systematic variance and its non-systematic variance of returns is equal to the asset's beta, total risk, or total variance. Well, we're adding two things. We're adding systematic variance and we're adding non-systematic variance. Systematic and non-systematic is total. It's total variance. We're adding variance. It says basically straightforward in the question, right? Next, an analyst gathers the following information. We got 3 securities in the market, along with their expected annual returns, expected standard deviation, and the correlations between the security and the market. Which security has the highest total risk? Well, for highest total risk, all we have to do is look at security 1, 2, and 3, look at the standard deviation, and choose the highest one, right? What do we got here? There it is right there. Security number 1 has the highest total risk. What do we say when we get questions like this? Too easy, drill sergeant. Which security has the highest beta measure? The highest beta measure. So we have to calculate beta. Do you remember how we calculate beta? Remember, beta was the correlation between a particular security in the market multiplied by the sigma 1 over sigma m. There we go. So what is our correlation here is 0.6 for security 1, and we have 25 over 15. 0.6 of 25 over 15. You'll get 1 on that one. And this is for asset 1. Number 2, do we have to calculate 2? 2 and 3 have the same standard deviation, but they have different correlations. So we know we're multiplying out. Let's just take the one with the higher correlation. I know 3 is going to beat out 2 because it's got the same standard deviation, so the ratio will be the same under both conditions, but this has 0.8, so I'm just going to multiply the 0.8 by 20 over 15, and I'm going to get 1.06. I don't need to multiply the second one because I'll be just multiplying by 0.7. I'll get something lower. I'm looking for the highest beta measure, and that is simply going to be 19. I'm going to get, oh, sorry, hang on. No, security 3. Sorry, is C, security 3. Which security has the least amount of market risk? The least amount of market risk. So let's, we want the one with the lowest beta. This is 1.06. This is 1. So I know my security 1 has the lowest so far. Let's just calculate security 2. That'll be 0.7, 20 over 15, and that is going to give me 0.93. I know this is 1.06. I know that's 1. That's 0.93. So security 2 has the least amount of market risk. On this one here, security 2, least amount. With respect to return generating models, the intercept term of the market model is the assets estimated, and I didn't use the exact words revenue generating model, but we remember the market model, right? The return on any asset is alpha plus beta RM plus some error term. So it's saying that the intercept of the market model is the assets estimated alpha. B. With respect to return generating models, the slope term of the market model, is an estimate of the assets total risk, systematic risk, or non-systematic risk. Well, beta captures what? Beta captures our systematic risk. The epsilon term, the error term, captures our non-systematic risk. So it is an estimate of the assets systematic risk. With respect to return generating models, which of the following statements is most accurate? Return generating models are used to directly estimate the... Well, look at what it's saying. It's a return generating model. What do you think it's generating? Returns. A return generating model are used to directly estimate the expected return of a security, the weights of securities in a portfolio, or parameters of the capital market line. Well, if it's a return generating model, it must be a model that helps me generate returns. Expected return of a security. Let me write it out, see if that's what it does. Remember, the expected return is RF plus beta RM minus RF. What is that giving me? An expected return. Expected return. There we go. And with respect to capital market theory, the average beta of all assets in the market is... all assets in the market. What's the beta of the market portfolio? Equal to 1. And we're saying the average beta of all assets. If the average beta of all assets is 1, the market beta is 1, right? With respect to the capital asset pricing model, the primary determinant of expected return of an individual asset is the assets beta, market risk premium, or assets standard deviation. Some of you may already have the answer and saying, I know what it is. But let's just draw it out. Primary determinant of expected return. So we're looking at expected return is going to be the risk-free rate plus beta, RM minus RF. There's the capital asset pricing model. RF is going to be the same for all securities. RM minus RF is going to be the same for all securities. Beta is going to be security dependent. And it's saying the primary determinant of expected return of an individual asset is, well, the only thing that can vary with every individual asset, the beta, the asset's beta. With respect to the capital asset pricing model, which of the following values of beta for an asset is most likely to have an expected return for the asset that is less than the risk-free rate? So we're going to need RF minus something if we're going to have an expected return less than the risk-free rate. Well, the term in the brackets, RM minus RF, we don't know if that's going to be positive or negative. The only thing that will most likely lead to a negative is a negative beta. Do we have a negative beta anywhere? We only have one. We'll take it. With respect to the capital asset pricing model, the market risk premium is less than the excess market return, equal to the excess market return, or greater than the excess market return. Well, the market risk premium, RM minus RF, that is the excess return on the market. That is the market risk premium. The market risk premium is the excess market return. It is equal to the excess market return. It is the excess market return. It's not a question of it being equal to. It is. the graph of the capital asset pricing model is the capital market line, the security market line, or the security characteristic line. Remember now, once we moved from sigma to beta, we still had the same thing here. It still looked exactly the same, and there's the market portfolio again. It's got a beta of 1, but we no longer call it a capital market line. We're using beta. We call it a security market line. So the graph of the capital asset pricing model, which is what this is the capital market line, security market line, or security characteristic line. It is the security market line. With respect to capital market theory, correctly priced individual assets can be plotted on the capital market line, security market line, or capital allocation line. With respect to capital market theory, correctly priced individual assets can be plotted, well, it would be plotted directly on the line, so it can be plotted on the security market line. The capital market line, remember, was for well-diversified portfolios. The security market line is for individual securities and portfolios, and it's telling you correctly priced individual assets can be plotted on the security market line, not the capital market line. An analyst gathers the following information: security 1, 2, 3, expected standard deviation, and their betas. With respect to the capital asset pricing model, if the expected market risk premium is 6% and the risk-free rate is 3%, the expected return for security 1 is closest to. So security 1, we need an expected return, and it's going to be our risk-free rate plus our beta and our RM minus RF. Do we have an RF? Risk-free rate 3%, 0.03, plus security 1 has a beta of 1.5. The expected market risk premium is 6%, so everything in here is just 0.06. We're told the risk premium is 6%, not that the return on the market is. Remember, the excess return is the market risk premium, right? So what's that going to give us? That's going to give us 0.03 plus 1.5 times 0.06 is 0.09, 0.12, or 12%. Do we have that anywhere? 12%. We have the same information above here. With respect to the capital asset pricing model, if expected return for security 2 is equal to 11.4, so here we're given the expected return, risk-free rate is 3%, the expected return for the market is closest to. So expected return for any security is equal to the risk-free rate plus its beta times the return on the market minus the risk-free rate. We are given the expected return on this asset is 11.4%, is equal to 0.03, which is the risk-free rate, plus security 2's beta is 1.4 times the return on the market. We don't have it. We're being asked for what the expected return on the market is, so RM minus 0.03. And we'll just expand. 0.114 is 0.03 plus 1.4 RM minus 0.042. And if we rearrange, we'll get 0.126 is equal to 1.4 RM. So RM must be 0.126 divided by 1.4 is 0.09. We must have 9%. There it is, 9%. With respect to the capital asset pricing model, if the expected market risk premium is 6%, the security with the highest expected return is, well, let's have a look, the highest expected return. Notice that the risk-free rate in here, if we look at our formulation again, let me write it over again. Expected return is equal to the risk-free rate plus beta, RM minus RF. No matter what asset we choose, they'll all face the same risk-free rate, and they'll all face the same equity risk premium. So the highest return would belong to the highest beta. So all we have to do is just look down. Security 3 has the highest beta. Must be security 3. There it is right there, security 3. All right, we have the same information that we've been dealing with for the last few questions. With respect to the capital asset pricing model, a decline in the expected market return will have the greatest impact on the expected return of the greatest impact. So we know that beta RM minus RF, what we're saying is if this declines, well, everyone faces the same risk-free rate, so that can't affect anything. And if this declines, which one will have the greatest impact on the expected return? The one with the highest multiplicative figure, the highest beta. What do we have? 1.6. Still security 3. With respect to capital market theory, which of the following statements best describes the effect of the homogeneity assumption? Remember, the homogeneity assumption said all investors have the same expectations about returns, hence a passive approach is the way to go. Because all investors have the same economic expectations of future cash flows for all assets, investors will invest in the same optimal risky portfolio, the S&P 500 index, or assets with the same amount of risk. They would invest in the same optimal risky portfolio. With respect to capital market theory, which of the following assumptions allows for the existence of the market portfolio? All investors are price takers, have homogeneous expectations, or plan for the same single holding period. Well, we've already mentioned it before. We talked about the homogeneity of expectations, and if all investors had the same expectation, there would be one optimal portfolio that everyone would invest in. We then brought that that optimal portfolio forward and called it the market portfolio. They have homogeneous expectations. 3 equity fund managers have performance records summarized in the following table. We have manager 1, 2, 3. Their annual return, the standard deviation, given a risk-free rate of 2.6%, which manager performed best based on the Sharpe ratio. We know the Sharpe ratio is the return on the portfolio minus the risk-free rate over the standard deviation of the portfolio. So that's all we have to do. We have 3 returns on the portfolio. There they are. We're going to subtract 2.6 off of each of them and divide them by their respective standard deviations. 1.1187, 1.0472, and 1.2758. There's the highest one. We are looking for which manager performed the best. The best performance with a Sharpe ratio is the highest Sharpe ratio, manager 3. Which of the following performance measures is consistent with CAPM? And we did 4 of them. You remember we did Sharpe, and we did M squared, and we said these 2 dealt with total risk. Then we did Trainer, and we did Jensen's alpha. And we said that these dealt with just systematic risk, and of course we used beta in these, and we used variance in these, or standard deviation or variance. So, which one is consistent with CAPM? M squared or Sharpe? No, they're not. The only one here is Jensen's alpha, which is C. Which of the following performance measures does not require the measure to be compared to another value? And again, our 4 were Sharpe, M squared, we had Trainer, and we had Jensen's alpha. And the Sharpe and the Trainer had to be compared to the market. So these 2 had to be compared to something else. M squared and Jensen's alpha can stand on its own. And if we go this way, remember this was total risk and this was just systematic risk. So which one does not require it? The Sharpe ratio? It does. The Trainer plus beta RM plus epsilon. There it is right there. Analysts who have estimated returns of an asset to be greater than the expected returns generated by the capital asset pricing model should consider the asset to be overvalued, undervalued, or properly valued. Well, we're looking at the expected return of an asset, RF plus beta RM minus RF. More importantly, though, what will this do? What will this equation do? It will price assets out on the security market line, because you'll have the risk-free rate. Notice you have your intercept, which is RF, and it's a function of beta. So it will price it out on the security market line. This is saying, well, what if you do your own estimate and you say, well, I'm going to ignore the capital asset pricing model, and I think it's priced here. Well, clearly, if the capital asset pricing model is pricing it on the line and you're pricing it above the line, you would say CAPM looks like it's undervaluing that particular security. So let's read the question again with this in mind, and let's see if the answer doesn't jump out at us. Analysts who have estimated returns of an asset to be greater than the expected returns generated by the capital asset pricing model, in other words, up here, should consider the asset to be overvalued, undervalued, or properly valued. I think it's worth this. CAPM says it's worth this. CAPM is clearly undervaluing that asset. The intercept of the best fit line formed by plotting the excess returns of a manager's portfolio on the excess returns of the market is best described as Jensen's, this is too easy, right? Beta, ratio, or alpha. Jensen's alpha. Portfolio managers who are maximizing risk-adjusted returns will seek to invest more in securities with lower values of Jensen's alpha, values of Jensen's alpha equal to 0, or higher values of Jensen's alpha. Well, to get an idea of what Jensen's alpha was, here's our security market line. And so let's say that we look at the return of a security and we take the return of any security and we subtract what the return, we take the actual return and subtract what the return should have been given its level of systematic risk, which would be plotted on the SML. Jensen's alpha will give us, if we have a return higher, it'll give us this distance. That's what alpha is measuring, the distance above the security market line for the same level of risk. So if we want to maximize our risk-adjusted return, it's for the same level of risk, but a positive alpha means we're above the security market of systematic risk, which would be plotted on the SML. Jensen's alpha will give us, if we have a return higher, it'll give us this distance. That's what alpha is measuring, the distance above the security market line for the same level of risk. So if we want to maximize our risk-adjusted return, it's for the same level of risk, but a positive alpha means we're above the security market line. We seek to invest more in securities with higher values of Jensen's alpha. There we go. Portfolio managers who are maximizing risk-adjusted returns will seek to invest less in securities with lower values for non-systematic variance, values systematic variance equal to 0, or higher values for non-systematic variance. We want to invest less in, well, if we're going to maximize our returns, remember, let's just draw it out. Our expected return is RF plus our beta, RM minus RF, and we said that this is the determinant of the expected return of any particular security, is beta. Beta is a measure of systematic risk. So imagine that beta is now 0. If beta is 0, what do we got? The risk-free rate. If beta is negative, we got less than the risk-free rate. So the higher beta is, the higher the expected return. Since beta captures systematic risk, and we want to maximize our risk-adjusted return, we should seek to invest less in securities with, well, the opposite of systematic risk, which is non-systematic. We should invest less in securities with lower values for non-systematic variance? No. Values of non-systematic variance equal to 0? Well, no, because that would be pure values of non-systematic variance equal to 0 is exactly what we want, because we want the highest amount of systematic risk. Higher values for non-systematic risk. That is what we want less of. We want less of higher values of non-systematic risk. So our answer there would be C.